Bismillahirrahmanirrahim. Today we will start our 16th lecture of course Digital Electronics. In today's lecture we will study shift registers. It has four types: serial input, serial output, serial input, parallel output, and parallel input, parallel output, and parallel input, serial output. These are the four types of the shift registers. We will start our today's lecture from serial input, serial output register. In this we will have the serial input and the serial output. Our input is from this side. This is our input, and on the Q and naught or Q and 0 we will get our output. This is the clock which is connected. We will have the clock, then our clock is 1, like we are giving the first clock and our process starts. This 0 will be input and it will go at the place of Qn3. First of all we will write it as Qn3, Qn2, Qn1 and Qn0. On the clock 1, our 0 will be the input at the place of Qn3. This is our input, and the other inputs are that Qn3 will move forward, Qn2 will move forward, and Qn1 will move forward. So we will have Qn3 here, Qn2 and Qn1. After that, when we will give the second clock, our 0 will move forward and the 1 will be the next input at the place of 0, and 0 will move forward to the Qn2, Qn2 will move forward to Qn1, here we have Qn3, and then we have Qn2. After that we will give our third clock, so our 1 will move forward, 0 will move forward, Qn3 will move forward, and at the first place we will have one input, this one, and after that we are only left with the 0 here. So on the fourth clock 0 will move forward, all the values will step forward, 1, 1 and 0. So as we have serial input, serial output, so after 4 clocks we have the output 0 as we have the serial output. So serial, when we will go serial wise, we will have the output 0 after 4 clocks. On the 5th clock, as we have this as the output, our this one will move forward, this one will be here, and this 0 is here. On the 6th clock, here we have this one output. On the 6th clock, this one will move here. This is our third output on the 6th clock. And on the 7th clock, this 0 will be at Qn0, our output. So this is our final answer, 0, 1, 1, 0, which we have given the input. From here we can see that as we have n equal to 4, the total clocks we are using are 2n minus 1. That is 2 into 4 minus 1 is equal to 7. Total 7 clocks we are using. After that we will have, now we are having serial input parallel output register. In this register we are having serial inputs but the parallel outputs. Serial inputs but the parallel outputs. So for this we are taking our values 0, 1, 0, 1. As the clock is 1, our Qn3 will move forward, Qn2 will move forward, Qn1 will move forward. Why? Because at the place of Qn3 on the clock 1, as the clock is triggered, we will get our first value as our Qn3. So here we have 1. On the clock 2, 1 will move forward, Qn3 will move forward, Qn2 will move forward, and at the place of 1, now we are having our next input, that is 0. On clock 3, we will have our next input, that is 1. This 0 will move forward, 1 will move forward, and Q and 3 will move forward. Now we are having Q and 3 at this place. For the fourth clock, our 0 will be our next input. We will have 0, 1, 0, 1. Now we are having our all values 0, 1, 0, 1 as the output on the 4 clocks. As it is the serial input parallel output, different from the serial input serial output. As we have the parallel output, so parallelly we are getting all these values as our final answer output. As on the 4 clocks total, we will get our output. It is faster than serial input serial output register. Now we have parallel input serial output register. In this register, we have the parallel inputs. So we are taking the value 0, 111. As we have parallel input, so our first input is 0, 1, 1 and 1. We can give the parallel inputs. Now at the clock 1, we have all these values. As the clock is triggered, we will get all of these as the input. So 0, 1, 1, 1. On the clock 2, why we are using the clock 2? Because these are the parallel inputs but the serial output. On this output, we are having 1 at this time. Now to get all the values at the output, we have to do the other clocks also. So for the clock 2, this 0 will move forward, this 1 will move forward, this 1 will move forward. So on the clock 3, we will have, as we have this one here output, this one is output here, now this one is output here, and we are left with our only 0, and when we will give the fourth clock, this 0 will move to the final answer like this. Now we are having this 0 at the output. So this is our final answer. On the 4 clocks, we are getting our answer. That is 0, 111. This is our parallel input but serial output register. This is our fourth register, that is parallel input parallel output register. We are taking our value as 1101 as it is the parallel input and the same input we have as for the parallel input serial output. So for the input we will have 1, 1, 0, 1. This one is getting here as the input, this one is here as the input, this 0 is here as the input, and this 1 is here as the input. As we have the parallel output, so for this, on the clock 1, when the clock 1 is triggered, our inputs are 1, 1, 0, 1 on the clock 1, on the first clock. But as it has the parallel output, so as the 1 is entered, it will be the output. We will have it at the output. This 0 and this 1 will be at the output. So this is the fastest of all the 4. The parallel input, parallel output is the fastest register. That on the first clock, we will get all our outputs ready to use. 1, 1, 0, 1 is our final answer. So these are the 4 types of the registers.